Good evening, class. Here I'm going to run through what I did as far as programming and the general project for the tachometer. The first section we established all of our data types, we established our initial conditions, we established which pens do what, and we name them. The next one is we have our setup, we activate the serial, we defined what our pin types are and what type of data, whether it's output or input. We define the interrupt, and then we finally, our status pin, we also define what type of information that is there. We give some initial values, and we also greet the users with instructions about what we want them to do. We then have the fan function. A lot of this code was information given by the course material. We have our toggle LED logic here, and we also established the value for that pin based on the logic we show over there. And this will help it blink on and off to give us a visual indication. Next thing, we have our serial event. This is what this goes through every round, and it looks for information that you might have given the serial input. This information will be required to start and end the program. The program will not start unless it has the input for G, which gives it the device B, service device B, and for S it will be service device A, and that will stop the program. Most of this is done in the void loop, but if you go through and you do service device, if you put in the G, it will power up the fan and it'll power up the red LED. Then you have the void loop, which is the main function. If you have the service device A, that'll turn everything off and exit the program. If you have A, that'll start the count. And from there, what you'll be able to do is you'll go through the program, and first we will have initial delay. Then we deactivate the interrupt so it can do the calculations. A difference that wasn't here versus the examples given in the course material was I have a 3-blade propeller versus a 2, so I had to change that variable because instead of having the signal interrupted twice per revolution, I have it interrupted 3 times per revolution. So I've changed that value as such. It goes through here, it prints out the value, and then finally it will reactivate the interrupt so it can pick up data the next round and use that for the next round of calculations. This way it will not affect the data, and we can do our calculations without having compromised data. Now here's an example. We're going to have it run through the program itself. So we're going to open up the serial monitor. It's going to ask for input. We're going to give it a G. It's going to tell us what's happening. It's taking our data. Stop. It turns everything off. Hello again. So here we see the propeller, the brushless motor, which came from my Arduino kit, and we also see the setup we have all outlined in the PDF that I showed. You'll notice that I colored the blades of the propeller black because they actually were opaque, and just to make sure that we don't have any interruptions. So I'm going to turn on the fan. Put it into place. It's taking the data,